Hi friends, good morning. So this is Reshma. Welcomes you again to a session on database management system. And in today's session, I'm going to discuss with you a special derived operation in relational algebra. So that is here the division operation. This division operation is not a basic operation in relational algebra, but it should be derived with the help of the existing basic operations like unary operations and different binary operations such as select, project, union, set difference. So like this we have basic operation in relational algebra. With the help of those basic operations, this division operation is derived. Hence this come under division operation. So now here the question is, even if we are having some basic operations, then why we need to derive this division operation? In which situation we should use division operation? So now here the division operation will be used in special types of queries where we need to extract the data which will be applied to every tuple, which should satisfy every tuple, which should satisfy each and every tuple for the given condition. So we need to remember, whenever a query is given, to retrieve the data which include the keyword like every, which include the keywords like all. So it indicates that we should use division operation. And why I should use division operation once I find every or all keyword, so that we'll discuss in the next examples which I'm going to discuss here. So before going to the query writing using division operation, we'll see the basic functionality of division operation. So now here division operation will be represented like the same divide operator which you are using in any other course. And so this division operation is a binary operation which will be applied on two relations like R and S here. But when we are applying this division operation on these two relations, the attributes of these two relations should satisfy some condition. What are the conditions the attributes of each relation should satisfy? So here the R is the new relation placed in the numerator and S the relation in the denominator. The attributes of the relation in the denominator should be subset of attributes in the relation of numerator. So you can say here X is subset of Z, where X is attribute of denominator relation and Z is attributes of numerator relation. And as I said, division operation can be derived with the help of different basic operations. So once we'll apply division operation on relation R and relation S, that is on Z and X attributes, in the resultant relation we will get attribute Y. So how to get this attribute Y? The attribute Y is obtained by applying set difference on Z and X. So Z minus X will give us attributes for the resultant relation. So if I apply attribute of resultant relation and attributes of denominator relation, the union operation on these two will give the attributes of numerator, numerator relation. So that is here we have observed how the division operations will be derived with the help of the different basic operations. So now we'll see an example how the division operation will work. So now here I have relation R and S, apply division operation and the result will be stored in relation T. So now here I have two relations, R which contain attributes A and B, relation S contains attribute A, and the resultant relation name is T. So what should be the attribute in the relation T? This will be R minus S. So R minus S is B. So resultant relation contains attribute B. Then what should be the values in the resultant relation? So now as I said, division operation will be applied to identify the matching tuples for all the values of the denominator. So now resultant relation will contain attribute from the numerator by matching attributes in the denominator. So here relation in the numerator is R. Relation in the denominator is S. Then resultant relation is T. Now resultant relation will contain attributes from the numerator relation. So which value should be placed? I need to place those values of B which comes with all values of the denominator A. In denominator A I have A1, A2, A3. So now I need to decide whether B1 should come in result or not. So we can place B1 in the result only if B1 comes with A1, A2 and A3. Just check whether B1 comes with A1, yes. B1 comes with A2, yes. B1 comes with A3, yes. B1 comes with all values of the denominator relation. So B1 comes with A1, A2, A3. So result will have B1. Now check for B2. Shall I place B2 in the result? So I can place B2 only if B2 comes with A1, A2 and A3. So but here B2 comes only with A1 and A3. It will not come with A2. So we will not place B2. Similarly check with B3. So B3 also it doesn't come with A1, A2, A3. It comes only with A2 and A3. So no place for B3 in the result. Now I'll check for B4. So here B4 comes with A1, A2 and also A3. So B4 will come in the result. So like this our division operator will work on the two relations where it will match the condition for all the values of the denominator. Now we'll see some real-time example by taking a company database. Okay, so now here we want to write the query. So to retrieve names of the employee who work on all the projects that John Smith works on. So here you can see the keyword all. Whenever the question contains all, we should take the help of division operation. So what is the question here? We need to retrieve name of all the employees, name of the employees who works on all the projects that John Smith works on. So first here we need to decide which are the tables required. Then we write the query step by step. So here I need employee table. So from this I can derive the name of the employee. Then to know the projects, I can take the help of works on table and the project table. So now we'll write the query step by step. First what I will do, instead of writing the query on the whole employee table, I will extract. So because here I need to worry about we need to work with only John Smith. So first I will retrieve the data related to John Smith. So we'll write the query, select the details, select that tuple where name is John Smith, first name John, last name Smith from the employee. So then I have created intermediate table Smith. Smith table contains details about the John Smith. So now what I will do, we will identify the projects on which John Smith is working. Okay, so how to find that? So here we have written join operation on works on table and Smith table. Works on table contains the details are like ESSN, Queen number and hours, and we have Smith table which gives details of John Smith. So now apply join operation here. So we know join operation is Cartesian product plus select operation. So after Cartesian product, in selection condition is equalizing SSN with SSN of Smith with SSN in the works on table. So SSN of Smith is 1, 2, 3, 4, 5, 6, 8, 9. So now in the works on table we need to find on with the project's numbers where ESSN is 1, 2, 3, 4, 9. If I match this here, tuple 1 and tuple 2. Yeah. Okay. Only first and second tuples are equal to the SSN 1, 2, 3, 4, 5, 6, 7, 8, 9. So the corresponding project number is 1 and 2. So John Smith is working on two projects, project 1 and project 2. So now these projects we have placed in another intermediate table, Smith underscore project numbers. After finding the projects where John Smith is working, so now we need to find the employees who are working on all the projects handled by Smith, means the employees who works on the project number 1 and 2. So for that what we can do, so from works on table I have extracted only two columns, ESSN and P number, that I have kept in SSN underscore P numbers. So now apply join operation on SSN project numbers and Smith project numbers. So SSN project numbers contains all the projects where some of the employees are working. Smith project number contains all the project numbers where, on which only Smith is working. So these are the project numbers of PSSN and these are the project numbers handled by Smith. So now we need to apply here division operation. So division operation, so we need to decide. So here SSN P number is in the numerator, Smith P numbers in the denominator. Then the resultant table will contain, which attribute will be there in the resultant table? It will contain only ESSN. So now which value of ESSN will come under the result? So how to do that? We have to apply division. So if 1, 2, 3, 4, 5, 6, 8, 9, if it comes with 1 and 2, then that will come under result. So just check here. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. It comes with both 1 and 2. That will come under result. Can you check with 666? So 666 comes with 3. So it will not come under the result. 453, it comes with both 1 and 2. This will come under result. 333, it comes only with the 2. So now if I see the project number column in the SSN P numbers, there is no other project number which match 1 and 2. So in the result, I will get only 2 ESSN 1, 2, 3, 4, 5, 6, 7, 8, 9 and 453, 453, 453. So that is the result, and here we have created a new table with the name SSNS. Attribute name is SSN. So it is a renamed attribute. So like this we have extracted the required result from the relations of relational database. So this is about the division operation, and here we have observed how the division operation extracted the details which match with all the tuples of the denominator. So remember, division operation should use if the question contains the keyword like all or every. So this is very special derived relational algebra operations. So now I hope you understood the concept of division operation. If you have any doubts, please post your questions in the comment box. Thank you for watching the video. In my next session, I am going to discuss with you how to solving of different relational algebra queries. We'll try to solve simple and complex queries. So to get the videos on those classes, please click on subscribe button and click on the bell button to get the notifications immediately. Thank you.